Attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar on how facility management can overcome workplace constraints with wireless. I'm Ann Cosgrove, the editor-in-chief of Facility Executive Magazine, and this webinar is presented by Annexes and RF Connect. Thanks for joining us. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel that is on your screen. This is where you can submit questions in the question box contained in that panel. You can send your questions in at any time, and your speakers will address them directly after the presentation. Also, please note the orange arrow on the left side of that control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure it is expanded so you can access the question box. You can also use that question box to send us any questions if you have experiencing a technical difficulty at any time, and someone will address it right away privately with you. So now I'd like to introduce your two speakers today, John Caselli from Annexes and Dave Sherman from RF Connect. John graduated from Washington University in St. Louis, studying mathematics and linguistics. After a few years finding fun in both but pursuing neither, he embarked on his great wireless journey. And John's unique pairing of a desire to be in the trenches with business owners, along with a proclivity for solving complex technical puzzles, found a home at Annexes as the company's wireless manager for the Midwest. Bringing his technical acumen to real-world business problems quickly garnered John an industry position like few before him, and he continues to pursue increasingly intricate projects and is helping to lead the industry in the implementation of the 5G and IoT standards of the future. Second, you'll hear from Dave Sherman. He is Senior Solutions Engineer with RF Connect with over 25 years of experience in the RF and information transport systems industry. He's worked on numerous projects for Fortune 500 companies as well as government entities involving both new and existing facilities. He's worked in numerous capacities in the industry, including 10 years of field technician and foreman experience. He has been an RCDD since 1994 and certified to engineer and install several OEM distributed antenna system and public safety wireless systems. Along with those OEM certifications, Dave has attended numerous project management courses, including those sponsored by the Project Management Institute. His project team has engineered, installed, and commissioned more than 500 in-building wireless distributed antenna systems installs since 2008. So we'll be hearing a lot of good stuff from these gentlemen today. And again, please feel free to send your questions in at any time. We look forward to addressing those at the end. So with that, I'm going to hand it over to John Caselli. Hi, John.
Hi, Ann, and thank you very much. I appreciate everybody giving us a little bit of time today. So we're going to talk a little bit about how you can overcome some new workplace constraints with a specific address on wireless systems. So the agenda for today, we'll look at some building space utilization concerns, which include drivers and challenges as they relate to wireless communication. We'll highlight some trends that Annexes observed in the real estate industry, and then we'll look at optimizing the effectiveness there within some work areas, collaboration zones, common areas, and the IT space. And then I'll hand it over to Dave for some implementation considerations. For those of you who aren't familiar with Annexes, just a brief overview of who we are. So we're a 60-year-old company. We're probably one of the biggest Fortune 500 companies you've never heard of. We're traded on the New York Stock Exchange under the symbol AXE. We've got over $1 billion of inventory at any given time globally. We operate in 50 different countries in over 300 locations. And I think we're pushing close to 10,000 employees now. These are little bubbles a little out of date. So as we look at optimizing the effectiveness of our real estate, we've got basically three different drivers that we'll highlight. So generally speaking, we want to reduce the cost per square foot of any physical real estate. We'll look at better leveraging the facility and its resources, and then specifically catering those to the needs of the employee. So the big challenges faced by tenants and building owners, I think, reduce to three main categories. The first is adapting to a changing workforce and the growing cost of real estate. We see that prime-based real estate or urban-based real estate is really attracting the best talent, whether it's new talent coming out of trade schools or universities like the millennials, or it's highly sought after employees that I won't say old, but tenured. They don't have to necessarily be much older than the millennials, but certainly they're not new to the workforce. The second consideration is rising energy costs, which are driven really by utility demands like lighting and space conditioning, the electronics that we use and that are proliferating, which Dave will highlight a little bit more, and then just the IT process loads that go through any structure. And then third, really justifying the cost of refurbishing and doing upgrades to office space to provide more functional spaces, and then ultimately satisfying the occupational and ergonomic needs for the employee within those spaces. So with regard to real estate trends, we found a study from Cornet Global that highlights that approximately 88% of floor space in the next few years is expected to either shrink, which is the majority, 63% you see there, or stay the same. About a quarter of respondents indicated that they wanted to keep the same real estate. And then a few, but definitely a minority, said that they expected their floor space to grow. So within that shrinking or stable sized floor space, we see some other trends. Basically, we're looking at how people want to work together, which is changing a little bit. And really that change is driving the IT requirements of physical office spaces. And this effect of the IT requirements is being pushed further and further into wireless connectivity. As people are concentrated in smaller spaces, it demands more robust networks. And then collaboration areas are really the focal point of bringing new technology into some of these office spaces. And then for better or for worse, and I think it's definitely for the better, facilities management has to bring IT really into the fold so that they're no longer an offshoot of either operations, but really have to become a key part of business strategies going forward. So that begs the question, sort of, where do we work, right? So how this is changing within the office space. And I guess as you look at this picture, as you go from right to left, that's kind of a good indication of where I spend my time in Annexter, right? I do quite a bit of travel. So I'm primarily off-site, usually, whether that's at a customer's facility or just in transit somewhere. When I'm not traveling, I generally work from home. But as I'm out at various cities, I do stop in the Annexter branches, and then every once in a while, I'm up at our corporate offices in Chicago. So this is, I think, becoming more typical for a lot of employees. We're basically freed from the constraints of the desk. Now, not everybody travels as much as Dave or I do, so this is typical for us, but we can start to get a lot of our jobs done in a day-to-day manner remotely from a number of locations, either at a secondary site or back at the primary office. So this is putting an added emphasis on moving beyond, a standard LAN, whether it's wired or wireless, but also how we're communicating remotely, and then catering for individual office allocation when the worker is on site. So we see that from the end user's perspective, we're essentially in a digital workplace, right? So a study from Gartner in 2015 shows that the digital workplace is basically an area where we've got billions of bytes of data, if not more, where we're collecting that data, aggregating it, and we want to turn that into something useful, information that can be acted upon, which then we deliver back to the users. So we ask what are the processes and tools needed to achieve this. And then combined with that, we have a new wave of personalization. So this comes down to the choice in either a physical device someone's able to do work with. You hear the BYOD initiative, bring your own device. So no longer is there a stockpile of phones in a corporate closet, but employees are allowed to bring in whatever they want, right? A phone, a tablet, one of each. They're wearables, so now the new next generation of watches is a phone in and of itself. And on those, we have the choices of an app to use or to work. Are we working with your traditional Microsoft Office? Is it something open sourced or based in the cloud? Again, a lot of personalization there. And so those two really drive our solutions in the physical world. So we have to address the devices used to facilitate that work, and then the places where this work is done, and the physical infrastructure that supports the work collaboration and access to that digital workplace. So quickly, we'll run through, who is involved, what's involved, and where are we doing this and why. And then Dave will get a little bit into the how later on. But as you can see between the first two layers there, the who and the what is really everybody and everything within the facility. It affects all the employees regardless of where their division sits within the office or within a corporate structure. And it really, as the Internet of Things proliferates, we're starting to see everything becomes connected and everything has some data that needs to go somewhere. And we're tying that all in together to address in different ways all the different areas where work is done in a technologically enabled workplace. And then really the goal obviously is a better utilization of that space. So the Annexes Approach designates this through 5 different areas. I'll highlight just a couple, but we've got the general work areas, meeting places, common areas, and then we'll kind of lump electrical facilities and IT space into the same, and I'll call it technical rooms to go forward. So within the work area, and this would be just general office, right? So low-walled cubes. But a couple of the considerations is, what's the risk of unsecured storage? Do people have personal items just at their desk or their lockers? How do you manage hot desk or hoteling? Again, I referenced that I'm not always in an office. I don't have a desk in an office somewhere, but when I am there, I do need to sit down and do some work. So part of that consideration is looking at what's the ratio of permanent versus visiting staff to any given location. Do you have an ergonomics policy and strategy, and that addresses some degree of LED lighting or smart lighting? And if you've got something like smart lighting that's generating data, how are you connecting that to a system, wired or wireless, and getting that data back somewhere where it's usable? And then some considerations to improve the effectiveness of this are, like I mentioned, locker facilities, occupancy sensors, mobile connectivity, and then LED lighting solutions as well. If we move to our collaboration zones, to consider the space utilization of those, what are your conferencing methods? Do you do video conferencing primarily? Is it just conference calls? Video is a very bandwidth heavy item to push across the network, so it can certainly be done wirelessly. Just need to make sure you've got the right considerations up front. And then how do you maximize your user experience? How easy is it to get connected to projectors or screens? Is there a standard wireless log on, either through a VPN or through a guest network if it's a remote presenter or a guest presenter? And then do you have meeting room standards? Do you have defined specifications for breakout areas or small versus medium versus large meeting rooms? And then solutions for that include obviously the technologically integrated furniture, IP-enabled audiovisual solutions, and then high-density wireless coverage. So if we move to common areas, some considerations there is do you have a visitor management process? This obviously often includes a front desk. Do you share information within the common spaces? Are there wayfinding capabilities like with Bluetooth beaconing or through a specific guest AP network? And then do you provide public network access, or is there a log on that somebody manages there? And then solutions to that, of course, are your visitor registration tools, which might include digital signage, certainly DAS, which is a cellular connectivity within the building, various Wi-Fi solutions, all of which can be pre-configured and installed by professional integrators like the RF Connects of the world. And then lastly, the IT space. Certainly you don't have employees hanging out there too much, although there are some. And we want to consider the appropriate floor space required to support technologies of now and of the future. So planning for that, do your IP closet or IT closets cater for growth? In terms of considerations for wireless coverage, are your data centers and tech centers covered with wireless, and that includes both cellular and Wi-Fi? How do you typically use your IP technology in meeting rooms? And do you have an on-premise or off-premise data center? Is that something that is located within a multi-tenant data center, or is it use edge data center solutions? as some of the best practices for maybe making that space either usable or rentable out to a client. So with that, I'd like to turn it over to Dave Sherman from RF Connect, and as mentioned, they're one of Annexter's best RF integration partners. And he's going to explore a little bit more about specific wireless considerations and implementation strategies for some of the items that I've spoken about here.
So as we move into the second half of today's webinar, let's consider some data points to emphasize the need for multiple wireless networks, that's high performance wireless networks in our facilities. What we need to consider is the massive growth of wireless devices. And as we look at the chart here, we can see that most of the device growth we're going to see is related to wearables and IoT devices that will have many different capabilities. We need to consider that our employees, visitors, contractors, and service providers are now bringing in wearables, smartphones, tablets, and with the advent of cloud-based services, we need to be able to support mission-critical business networks with wireless capabilities. Mobile connectivity in the cloud is now a must, and anytime, anywhere, and from any device is demanded. Carrier-grade quality of service is expected and demanded, and this poses an ever-increasing challenge when paired with the major growth of devices and the sheer volume of data being transported on our wireless networks. In terms of IoT devices, there's a couple different types of devices. One would be a high bandwidth device, could be a security camera, video devices, access control related devices, and the second would be low bandwidth devices that may control heating, ventilation, air conditioning systems, monitor lighting controls, occupancy sensors, and many, many more. In order to support this growth, our networks continue to need to evolve. John kind of led off and talked a bit about bring your own device initiatives. And just as a data point, many corporations are now embracing bring your own device initiatives. Currently, there's 89% of all enterprises that are supporting or planning on supporting bring your own device initiatives. And if we look at success in today's business environment, one of the keys is to be able to recruit and retain highly talented team members. Not only is recruiting our talent key to our organizations, but in terms of retaining them, employee satisfaction is very high on the list. It's also a fact that millennials are quickly being integrated into leadership positions within our organizations. And there was a Forbes survey done that indicated that by 2020, millennials in the workforce are projected to number 86 million, which would be 40% of our workplace. And then when they went further to ask them what it is makes them happy in the workplace, 88% indicated they prefer a collaborative environment. Thinking about that, it's meeting collaboration, drop-in meeting rooms, flexible workspaces, and being able to use the same devices in the office, on the roads, in their homes, wherever and whenever. 74% wanted flexible work schedules, anytime, anywhere, any device, and they'll require access to corporate networks as well as cloud-based resources. And 88% talked about work and life integration. This is different than what we had in the past, where many of us thought of it was important to be able to separate our work life from our home life. And now what we're finding is the millennials want to be able to seamlessly roam in between their work life and their social life, at work, at home, and be able to have the flexibility to do their jobs anywhere and anytime. So what's going to be required in order to give this anytime, anywhere, any place connectivity? It's going to be multiple networks, all using wireless systems. We have commercial DAS systems such as AT&T, Verizon, and Sprint. All of us are familiar with those, and all of us want to have those supported inside of our buildings. And as a key point, in today's environment, most of the colleges and large corporations, in order to be able to notify occupants and students and those inside of their buildings of an incident, They're using mass notification systems, which typically involves text messages being sent out to the cell phones of the students or occupants, employees within the space. If you don't have commercial carrier support inside of the building, they simply won't get the message, so your investment would be for nothing. In terms of public safety, there's new systems out there, emergency radio responders. Typically, they need to have coverage inside of the building, and we'll talk a little bit more about the codes that are involved with that in the next slide. And we also talked about IoT devices, machine-to-machine building management systems, surveillance, access control, lighting, digital signage. You can see all of these systems and all of these applications require wireless network connectivity and a high level of quality of service. So what about those first responder radios? The theme of this was workforce productivity, but today we need to be able to think about the safety of the occupants of our buildings. In-building public safety radio coverage is now part of many national codes. You'll see 3 of them here, which is the IFC, NFPA 72 and 1221, and local codes insist that we install and be able to support first responder networks. What are these devices? Usually they're two-way handheld voice-only radios, but they also have the potential that FirstNet provides for us, and that is a 700 LTE based network so that first responders can use 4G services. What that will enable them to do is when they respond to a medical emergency, they'll actually be able to go and dial up a doctor and send biometrics, and the doctors or those doing the treatment will actually be able to see the patient. So this greatly increases the outcome. And then lastly, we see that in order to be able to get a certificate of occupancy, more often the case is you have to support first responder radio frequencies in the building. And these are engineered systems. So carrier networks, they've become a critical component of a public safety first responder network. And we can see that 80% of E911 calls originate from a cell phone, and 70% of those calls are made from inside of a building. And we talked about mass notification systems and how they rely on carrier-based text messaging services. And we need to consider that all areas of our buildings need to be covered. In an emergency, the first place that people tend to go is to areas of refuge. They try to go to egress stairwells, back office areas, storerooms, sometimes restrooms. And as these are the first places that people flee to, a ubiquitous designed wireless system, distributed antenna networks required to be able to guarantee coverage in these spaces. So what have we learned? We have an increasingly complex wireless environment, and we need multiple networks in order to meet the needs of our occupants, first responders, and our network connected systems. So there's many different types of wireless networks that we can discuss. Primarily there's 3. One's the distributed antenna system. These systems are typically deployed inside of buildings that are in the range of 100,000 square foot plus. And a distributed antenna system offers the tenants improved cellular coverage in the buildings, and by the nature that they don't have because of the nature of the building and construction. Small cell solutions are now being deployed by the carriers. These are systems that are directly connected to carrier networks, and typically they'll service areas of 50,000 square feet or less. And then finally, Wi-Fi can extend the coverage range and fill in holes within inside a distributed antenna network system. And then there's public safety that we also need to consider. So what are the drivers that we need to consider when we're doing a design or planning for a public safety or distributed antenna system? And what determines the type of DAS that we need? The type of facility is one of the key things. Are we in a hospital, Are we in an office space, a mall, government facility? Could be stadiums, dorm rooms. All these have different requirements. The next is the size of the space. The larger systems typically have more extensive systems that need to be designed and implemented, and the smaller sometimes can be a single small cell. And then the last thing to consider is, what is your corporate or your facility's infrastructure strategy? Are you deploying horizontal fiber out to the workspaces, horizontal Cat6? Essentially, IP to the edge and connectivity to the edge is going to be needed to support 5G. And lastly, building codes. Are you required to put in a first responder network? Sometimes you can share the resources for both networks. One thing is, who pays for my DAS? It's great to need one, but how do I pay for it? Well, there's several funding models out there. Probably the first one was the carrier funded systems. These were widely deployed going back 5 years plus ago, and they're no longer really a viable model unless you have a very, very large facility, a stadium with a lot of visitors, a lot of very high visibility. So some think that carriers are paying for networks and in-building systems, and typically we find that's no longer an option. The second model we want to talk about was third-party operators. Companies like American Tower, Extenet, Crown Castle, Boingo, just to name a few. They'll come in and implement and essentially control your network for a period of up to 20 years. And what that does is you sign a contract that can essentially lock you out of upgrades being made. You're beholden to them as to when they want to upgrade your network. And this causes concerns for some organizations that don't want to be saddled with an obsolete system that they can't make changes to. The third and most flexible form of funding is the builder or enterprise funded option. This option offers the highest level of freedom and flexibility for the owner and the operator. And if you build your own system, then you're free to implement any upgrades, make changes to it at a pace that you determine, not determined by some third party. And quite often what we're finding is the carriers will fund a signal source. So they'll provide the equipment to connect to their network inside of the building, and then you just have to wire the building, the distributed antenna network system throughout. So that would be funded by the enterprise. And then the last model is those that might be interested in an OpEx versus a CapEx model. There's a funding model that essentially looks like a long-term lease. Typically, these are 20-year contracts, and you pay a monthly fee. And what you get is, in essence, a managed service where you have a controlled monthly spend, and the operator will pay for the upgrades along the way, and that's all built into a base fee. So RF Connect routinely helps our clients sort through these various funding models and helps them to determine which is best and which fits them. So what's the process look like? This is a flow chart, shows the DAS implementation process. You see from the start to the end, there's a lot of separate tasks like preliminary design and pricing and ordering of equipment and installation and making the system operational, maintenance and monitoring. But you see with all the steps, what this shows, it's extremely important that you select the right partner or integrator to work with to have a successful network implementation. So what's the process look like? We can kind of step through it, but stepping into it at the onset, you see that you need to do some needs analysis and planning. What this involves is determining which carriers the customer wants to bring on. Does he want to bring on 1, 2, 3, 4, or all of them? Will there be public safety network required by the AHJ? Certainly, if it's not, then the building owner will want to do it anyway. We can see that public safety and the wellness of our employees and visitors is key and critical. And then do we want to add Wi-Fi onto the system? So once you understand the requirements, you can create a plan and come up with some rough order of magnitude budgetary pricing numbers just to see how affordable the system is. And once you figure out about what it's going to spend, what we do is we come in and do benchmark testing, which means we'll bring equipment in that essentially connects to the carrier's networks and samples the data speeds, call connectivity, call quality, and essentially captures the existing RF environment so that can be a baseline for your design. We'll also do a walkthrough and consult the building facility managers and kind of look at the telecom head end, look at the remote closets, look at the pathways to make sure that when we do a design and create a preliminary design that it will fit the building and be constructible. And the piece that people are most interested in and seem to have the most questions about is carrier coordination. What does that mean? Well, the carriers own the spectrum essentially. They have licenses from the FCC that give them the rights to allow you to rebroadcast it or to shut it down. So the carrier coordination process usually involves getting some contractual agreements put into place that allows them to access your building, and there's just more of the legalese in that. And then they also want to see this preliminary design to see and ensure that when it gets turned on, it doesn't interfere with their network and it provides a high quality service for their customers. Once the carriers come in and give approval, typically what happens is there'll be some minor changes that need to be made to the design, and then the system installation process can begin. What RF Connect does and what we help with is obtaining multiple install bids from the cabling contractors. Could be your contractor of choice that you'd want to come into your facility. Could be the electrical contractor that won the bid on a new build. But essentially we put together a scope of work and design package for them so that we can get pricing. Once the system installation is completed and all the cables are tested and everything's correct, then the commissioning process can take place, and that is turning on the equipment in the head end, connecting it throughout the building, and then basically repeating the benchmark testing process to make sure that the design benchmarks and guidelines and goals are achieved. And next and last, you move into optimization and maintenance. So typically you'll want to have maintenance agreements associated with all of your DASs to make sure that they continue to operate in an appropriate manner. So this is a sample design. There's many types of DASs that are available today. Many might be familiar, but there's three of them that are the most common. One is a hybrid fiber coax system where you have coaxial cables out of your wiring closets out to remote antennas on the floor. Second would be a category 6 based UTP type version that looks and feels a lot like the cabling for your Wi-Fi and your desktops. Same form factor. And the last and the highest capacity offering is fiber to the edge. So they'd be running single mode fiber optic cables out to each one of the antennas or remotes that are out on the system. So let's look at this sample design. This particular one is a Cat 6A or a UTP variety. So all of the blue cables running out to the remotes on the far right, that's all category 6 cabling. And working from left to right, the first box on the left you'll see is the preliminary, or this would be a head end location. So this would be in a main telecom room. All the carriers would bring in their signal. There's multiple bands they bring in and their equipment would be located there. And what the system does is take all of the carriers' signals, combine them all together. They're all analog at that point, and then put them, convert them over to from an RF to a fiber optic signal, where it's distributed very much like your corporate network from the head end location out to remote. So on the right side, you'll see what it looks like switches. Essentially, what those devices do is take the fiber optic signal, convert it back to RF, and send it out to the active remote units in the ceiling throughout the space. The interesting thing about these is they look and feel a lot like your wireless access points. So here's a sample heat map. So what this is this is an engineering facility that we did a design for, a testing lab, and they did some shipping and receiving out of it. But all the black dots inside of the space are these active remote units that connect to the carrier network. And as you see, as you get further away from them, you can see how the colors change from the purples to the reds to the oranges and yellow. And this is basically the signal level decreasing as it goes through walls and over distance. And it's important that you do this design work up front. Without it, the carriers won't approve your network. So let's talk about putting it all together. Now, this is a slide that's been around for a long time, but what we like to talk about is a wireless utility network. We can see all the possible things that you consider for your wireless network. There's paging, could be in hospital applications, cellular, video, Wi-Fi, two-way radios. A lot of times the organizations we deal with have radios that they use for maintenance within their facilities. And then we have security systems, telemetry. We talked about public safety. And then there's all the Internet of Things type applications that if you start at the beginning knowing which parts you need to integrate in here, you can save a lot of money by being able to place them all on one or two networks instead of vast quantities of them. So we talked about how important it is to have a good partner and pick the right partner. So what would you want to look for? First and most important is probably the carrier connections and the carrier relationships. Being a nationwide approved vendor for the major carriers like RF Connect, we have relationships with AT&T, Verizon, T-Mobile, Sprint, and a lot of the local carriers, and we can help you in the implementation process. You want an organization that has their own design tools and equipment. These tools are extremely expensive. The benchmark testing that we bring into the facility, it samples the carrier signals and does the testing. That's probably a $70,000 to $80,000 spend, and many organizations outsource that, and of course, then you don't have control. You're looking for somebody who has manufacturer training and certifications. You want to ask, because just sending a technician out in the field without the right training is going to result in an underperforming network or one that doesn't work at all. You want somebody that's successful in large projects with union labor, FCC licensed engineers, RCDDs, and professional project managers on staff. If these are the folks doing your design work, you'll be assured that you get a good build and good working network. Wi-Fi and public safety first responder experience is also key. Now we can start integrating Wi-Fi over some of the distributed antenna system cable plants, and the first responder is very, very important, because if you need to meet all of the performance requirements before you can get certificates of occupancies. And IP infrastructure experience is also extremely valuable. Most of the endpoints we have in our networks now are IP based, so you'll want somebody that has experience in that arena too. So let's talk about our approach. RF Connect likes to function as a technical advisor to educate our clients, assess their needs, and determine the correct wireless solutions to fit them. RF Connect's a recognized leader in the industry. We have the trained personnel and the experience, and we've deployed thousands of networks with all the major equipment manufacturers. So what that means is we're going to interview the clients, we're going to do what's right for them, and we're not going to push one solution, that solution that works best for us on them, but the one that works best for the client. Been in business since 2004. As I said, thousands of successful turnkey deployments. And we're located throughout multiple facilities throughout the nation, so we can serve you with the local presence. And we've worked in just about every kind of building there is. You can see the list there, but one of the largest was MD Anderson, which is 10 million square feet of hospital campus and research facility in Houston. And recently we just completed the Toyota headquarters facility in Dallas. Once again, what we do for our customers, there's assessment, design, with the goal of eliminating dead spots and capacity challenges. We also are signatory, or we sit on the board of the Saveur Buildings Coalition. The whole goal of that organization is to provide the highest level of service and information in the build out and requirements for first responder networks. And we also have our own NOC, where we provide ongoing monitoring and maintenance out to our client base. That moves us into Q&A.
Thank you. Thanks, Dave. And thanks, John, for the first part of the presentation. And we will jump into about 10 minutes or so of Q&A. So we'll dive right in. Thanks for all that broad information. And we welcome anyone to continue to send in their questions. So the first question I'll ask has to do with workplace trends and space planning and some things that are near and dear to facility managers' workplace tasks. And my question there is, in the beginning, John, you mentioned some trends, and those included more dense spaces in terms of denser footprint, more people and more space in the workplace, in less space, I'm sorry, in the workplace, as well as more collaborative spaces being designed in to new or existing spaces. So in terms of density and or collaboration hubs and that trend, can you talk about, either of you gentlemen, about how that kind of plays into evaluating a wireless infrastructure? What are some building blocks that a facilities person should look at, and what can they expect to hear from service providers like you in terms of meeting the needs in either of those conditions?
Sure. So I'll start, and I'm sure Dave has something to add. But the couple of considerations would be that we're looking at not only increased amounts of people within those spaces, but actually devices as well, right? So I guess one of the first considerations would be when you hone in on a particular space, whether it's generic office space or if it's a collaborative zone, really to ask what's the goal of providing robust wireless coverage there, or what type of wireless coverage is needed. So is it a place that's strictly employees, but we know every employee on average has 2.1 devices, but those could be tablets or phones or computers, and really starting from there and then sort of growing out. Obviously that consideration is a bit different than your central lobby, for example, where employees typically don't stay. They enter, maybe greet a customer or a guest, and then take them in or out, as it might be. So there's mobility concerns there that might not be present in a meeting room where people come in and they're there for 30 minutes to 4 hours, but they're there to stay. So I would start with those considerations, and generally that leads to a question as well: do I need a DAS, or how robust is my Wi-Fi? And the answer is almost always that Dave and I found it's yes to both. So you need robust Wi-Fi to maybe do some offloading of the carrier signals from the DAS, but really both are needed for a high quality wireless plan within any space.
Yeah, and we're doing a lot of work in and around hospitals, and we know that medical imaging files are typically huge. We know that there's areas where they're performing x-rays that have lined walls to reject or RF altogether. So when you're looking at spaces like that, you need to consider putting devices, antennas, or remotes in just about every room. We know that surgeons are carrying their iPhones and scheduling their appointments in and out of surgical suites. So that would just be one example of a unique design. The second would be factories, working in a factory space. Generally, you're looking to cover a very, very large space in a lot of clutter. So a lot of times there's custom antenna designs and layouts that would be required. It all depends on the space, the size, and what you're trying to do with the network.
Thank you. Thanks. So from there, we hear a lot about, and we heard about it here in the presentation, about future-proofing infrastructure. Specifically, there was also mention of IT closets that cater for growth, but I think this question is more away from the IT closets, although feel free to mention, but it's more about future-proofing for the vast office space and workplace space. What does that mean, future-proofing? What kind of things do you talk to your clients about to save them time and money and headache down the road?
Well, one of the things we like to talk to them about is planning for and building out the best network that they can afford. And the trend now is to go to active remotes out to the edge. So it would be either fiber or Category 6 cabling out to all those antenna or remote endpoints out within the space. And by pulling fiber out there as opposed to coax, it gives you a lot more bandwidth out to the edge and capacity. We know that traditional hybrid fiber coax systems, they do a good job with cell phone connectivity and call connectivity and some of the current apps, but they most likely will not be able to support 5G initiatives and what that's going to do to the network. So we want to question them, find out what their goals and objectives are, and inform them so they can make a choice.
Thank you. So related to that too, what is the typical refresh cycle on these systems after installation? Obviously, you're trying to future-proof as much as possible, as we just discussed. But what is a typical refresh cycle, on these systems?
So the historical data on that, I wouldn't say it's misleading, but it's changing. So the typical refresh cycle to add a component from when we went from 3G to 4G, you probably had a DAS at least in for 3 to 5 years, depending on when it was installed, and because that was kind of the advent of the when DAS systems became necessary, is when 3G coverage was outside but not inside. And now our move from the 4G LTE to 5G is probably going to happen within the next few years. So you'd see that those systems that were either installed after 4G came around probably have been around for 5 to 7 years. And I would say it might stay like that, but with the move of DAS systems away from being funded by the carriers to having the enterprise or building owners fund them, the DAS OEMs have made their systems far more modular than they were in the past. So there's a lot more just modular upgrades, whether it's in the telco closets or the head-end room, that can be done to keep up with the service levels that are the same as outside, than perhaps in the past where you might need just a complete forklift upgrade.
And also another question along those lines is, aside from actually refreshing an entire system or modular upgrades, what if a system is in and it's operating as expected and it's fairly new, let's say, what type of ongoing expenses can a facilities person expect? Maintenance agreements were mentioned. Maybe that's part of it.
Yeah, so you certainly want to cover any system you implement with a maintenance agreement, and that'll cover annual health checks. We know the first responders, the authorities having jurisdiction, typically they're wanting to come out and do an annual inspection when they check your fire alarm systems, and typically they want to retest the first responder radio system. And then you want to plan for some moves, adds, and changes that may be needed in order to accommodate changes in your building environment, but those are somewhat limited.
And what about securing the system? Oh, I'm sorry. Go ahead, John.
Oh, I was going to say, just by and large, once a system is in and it's operating well, other than just an annual check to make sure everything's still optimized, and then the electricity needed to run it, there's really no expense, typically, or no ongoing expense, I should say. There's typically the carriers for a DAS aren't charging a monthly fee to tie into their system. So it's relatively low on the operating expense scale.
Okay, great, thank you. So what about securing the systems in the facility? What kind of security or considerations do you all take with those systems, and what does that add to the facilities managers' concerns, if at all?
If you're talking about just securing the actual physical components in the system, typically they're co-located with the customer's network equipment, their switches, hubs, routers, all their voice equipment. So typically they're behind locked doors, and that is the physical security piece. We're talking about the security from a data perspective. essentially, if you're on a carrier network with the Verizons or AT&Ts, they secure their own networks. So typically you get the same level of security that you're making and placing a call on an in-building DAS as you would outside. So there's really no extra spend there from securing carrier type networks.
Okay, thank you. Thanks for that clarification on both sides. So we have one last question here, unless anybody else has any more to send in. And that question is specifically about public response. That was talked about a bit as far as public safety and public response being able to be handled by a wireless infrastructure, and that's required in some spaces, from what I understand, some places, from what I understand. Can you talk about if there is an existing wireless infrastructure, what might be needed to kind of add that capability, or what does that look like if you have an existing building with some wireless and now you're required to add that public response capability? What does that entail?
So typically, now that the codes are starting to come out over the past 6 or 7 years, they often require battery backup for the signal sources and all the active equipment. They also require that the active equipment, amplifiers, bidirectional amplifiers, be in NEMA rated enclosures so that they'll take a direct spray of water without shutting down. So there's several matters of code that essentially would mean you have to, in order to meet the code, you'd have to pretty much redesign the system so that it does.
Interesting. Thank you. So most of it is that the physical hardening, so to speak, some of it. Okay. And go ahead, John. I'm sorry.
I would say that the good news, though, is that even as these codes become adopted either by local municipalities or statewide, as some of them move this into their FirstNet adaptation, is that we're not seeing AHJs come in and dictate that these systems have to be installed just out of the blue. It's really for new construction and then significant upgrades or remodels. And that varies, from AHJ to AHJ, but typically you're not going to get somebody to come in and say, you need this now, whereas you didn't in the past. It has kind of sort of has a grandfather clause into it.
Great, thank you. So any closing comments? I think we're almost out of time. And any closing comments from either of you?
No, just again to thank everybody for their time. Obviously, our contact information is up on the screen. So if you have any questions, feel free to email or call Dave or myself. But I appreciate everybody giving us an hour this afternoon.
Yeah, likewise, John. Appreciate the time that you've spent with us. And our goal is to serve as a consultant and help out all of our customers to be able to have successful implementations.
Thank you. Thanks, John, and thanks, Dave, for presenting, and to Annexter and RF Connect for sponsoring this presentation, and of course, to our audience for your attendance. A recording of this webinar will be available online for future reference at facilityexecutive.com, and that will be up in the next day. And thank you very much. Have a great afternoon.